What if I told you that the secret to the next massive breakthrough in artificial intelligence wasn't a trillion-dollar supercomputer?
Oh, yeah. It's actually the exact opposite.
Right. What if the secret was actually a severe lack of microchips? Welcome to today's Deep Dives. We are so thrilled to have you here with us.
We really are.
Today we're dissecting a super fascinating essay from Tech Reader magazine. It's titled, DeepSeek, A Parallel History of Chinese AI MD.
And this is the revised edition, subtitled With Chinese DNA.
Right. And our mission for this deep dive is to explore how a completely different philosophy of engineering, like one driven by strict hardware constraint rather than endless abundance, led to a global AI breakthrough that just completely caught Silicon Valley off guard.
But before we dig into the actual mechanics of this, I do want to clearly state something for you listening.
Yeah, good call.
This essay inherently touches on, geopolitical themes, national strategies, and basically the competing technological models of the United States and China.
Heavily debated stuff.
Exactly. So our goal today is absolutely not to take sides. We're not endorsing any specific political viewpoints or economic models here.
We're just the messengers.
Right. Our job is purely to impartially unpack the historical and technical narrative that the author presents. We just want to analyze the engineering, the history, and the philosophy of this parallel timeline.
Okay, let's unpack this.
Yeah.
Because the core thesis here completely upends the narrative most of us have internalized.
Oh, absolutely.
The standard story is that AI dominance requires endless scale. Bigger data centers, more energy, just
throwing massive amounts of hardware at the problem.
Exactly. But the essay argues that while the U.S. was operating in this reality of total abundance, China was forced onto a parallel track defined by severe limitations.
Yeah.
And to understand how that happened, we actually have to rewind to the very beginning. Let's look at 2015.
Yeah, 2015 is really the critical divergence point here, because in the American timeline, that's the year OpenAI launched. And in the U.S., AI at that exact moment was viewed as this exciting, highly speculative new frontier. It was basically seen as a super ambitious project.
But the author observes that when OpenAI launched, the reaction in Beijing wasn't panic.
Not at all.
There wasn't some mad scramble to suddenly spin up AI labs just to catch up with Silicon Valley. I mean, the Western narrative often assumes China's AI journey is purely reactive.
Yeah, that they're just copying.
Right. But the essay points out they had been laying the groundwork long before 2015. You had Baidu's Deep Learning Lab, which was actually led by Andrew Ng at the time.
A huge name in the field.
Exactly. You had Tencent's AI Lab, Alibaba's Demo Academy, Tsinghua University. They were already publishing top-tier deep learning research.
They really were. And they were doing it because, well, for China, AI wasn't just a speculative project. It was a structural necessity. The essay makes this really powerful distinction. In America, AI was a project. But in China, AI was a civilization.
That's a great way to put it.
Right. I mean, China already possessed the world's largest mobile internet market. They had the most integrated digital payment systems, the most advanced manufacturing supply chains.
So it was already everywhere.
Exactly. Integrating machine learning into that massive digital infrastructure was just the inevitable next step, just to keep the whole machine running smoothly.
And that structural reality totally changes the motivation. It wasn't about building an artificial brain in an isolated lab. It was about optimizing a digital civilization that was already up and running.
Precisely.
Which brings us to a massive technological shift in 2017. Google researchers published the famous paper, Attention is All You Need.
Ah, yes, the introduction of the transformer architecture.
Right. Now, I know the U.S. recognized this as a breakthrough, but they largely treated it as just one of many options on the menu for natural language processing.
Whereas the Chinese tech ecosystem recognized the implications almost instantly. They essentially pivoted their entire research apparatus toward transformers.
Which is a massive risk. I mean, if you're a giant tech company like Alibaba or Baidu, why pivot so fast?
It's a huge gamble.
Yeah. It's like entirely rebuilding your ship while you're already out at sea. Committing your entire infrastructure to one new paper so aggressively seems reckless, unless you know something the rest of the world doesn't.
Well, what's fascinating here is the underlying structural reason for that exact pivot. It wasn't just that transformers were generally more efficient across the board. It was that transformers solved a deeply specific problem for Chinese researchers. And that was the sheer complexity of the Mandarin language itself.
Right, because prior to transformers, natural language processing relied heavily on recurrent neural networks, or RNNs.
Right, the older models.
And those models read text sequentially, right? word by word or character by character.
Precisely. Think about it like reading a book through a tiny peephole. You only see one word at a time.
Oh man, that sounds exhausting.
It is. And by the time you get to the end of a really long sentence, the model has somewhat forgotten the exact context of the beginning.
I see.
Now, Mandarin is incredibly dense and highly contextual. A character's meaning can change entirely based on characters much further down the sentence. So sequential processing was just a massive bottleneck.
But the transformer architecture changed that.
Exactly. It processes entire sequences of text in parallel. It essentially takes away the peephole and lets the model look at the entire page all at once.
Wow. Okay, so it wasn't just them recognizing a clever algorithm. It was a literal lock-and-key moment.
Yes, exactly.
The transformer was the exact mathematical framework they needed to decode the density of their native data. And the timing aligns perfectly with state strategy, too.
Right, the 2017 push.
Yeah, right around this time, Beijing released its National AI Development Plan, explicitly targeting global leadership by 2030. So you have this top-down mandate to scale ambition, and suddenly the engineers have the exact tool to execute it.
It was a perfect storm.
Yeah. Baidu begins integrating transformers into their ERNIE models. Huawei kicks off research for Pangu.
They seized it as a massive infrastructural breakthrough. But, building that kind of infrastructure requires resources.
Lots of them.
And how those resources were managed is really where the two ecosystems severely split. By 2019, the U.S. approach basically becomes defined by centralization.
Like the Microsoft OpenAI partnership.
Exactly. The strategy there was to funnel just an unprecedented amount of compute power, primarily through Microsoft's Azure cloud, into one dominant entity backing one massive vision.
It's what I call the skyscraper approach.
Yeah.
The U.S. was building a single, heavily guarded, state-of-the-art skyscraper, just pouring all this steel and glass into making it the tallest structure on Earth.
I love that analogy.
But China looked at that centralization and went the total opposite route. They built a sprawling, highly dense, maybe slightly chaotic city block.
A federated ecosystem.
Exactly. You had Baidu, Huawei, Alibaba, iFlyTech, and all these various academic labs, and they're all building their own massive GPT-class models simultaneously.
And that federation created really intense domestic competition, sure, but it also built incredible resilience.
Right, because if one lab fails, it doesn't doom everyone.
Exactly. If one lab went under or if they pursued a dead-end architecture, the broader ecosystem didn't collapse. The neighborhood kept functioning.
That makes total sense.
And behind the scenes, the government was already conceptualizing a national compute grid, basically a distributed GPU backbone meant to support this multiplayer ecosystem as a shared utility.
But building a dense city block of AI labs creates a massive, almost insatiable appetite for compute power.
Oh, absolutely.
An appetite that collided violently with reality in 2021. In the U.S., 2021 is the era of total abundance. Silicon Valley realized the scaling laws were real.
Right, the idea that bigger is always better.
Yeah. If you make the model bigger and feed it functionally infinite compute, it just gets smarter, like with GPT-3.
But just as the U.S. was turning on the infinite tap, the hardware tap for China was forcefully shut off.
The export controls.
Exactly. U.S. export controls tightened severely. Suddenly, Chinese labs couldn't get their hands on the cutting-edge GPUs required to play that brute force scaling game. The high-bandwidth chips you need to train massive models were restricted.
They hit a wall.
Yes. They hit what the author explicitly calls the compute wall.
I mean, if your competitor across the ocean has a limitless supply of the fastest chips in the world, and you are suddenly stuck with hardware that is like 2 generations behind.
You can't just try to outscale them.
No, it's a physical impossibility at that point.
You have to fundamentally change the math of how you build AI. Chinese engineers were forced to ask questions that Silicon Valley, bathing in all this abundance, simply didn't need to ask.
Like what kind of questions?
Like, how do you train a frontier-class model on outdated, slower hardware? Or how do you dramatically slash the memory required just to run these models?
This means diving into techniques that sound incredibly esoteric, but they're actually the secret sauce of their survival. Concepts like low-precision training.
Yes, the essay mentions this as a massive pivot.
To use an analogy, it's like doing complex calculus. The U.S. models were doing the math out to 10 decimal places, right? Highly precise, but it takes a ton of time and a massive amount of memory.
But Chinese researchers realized they didn't always need 10 decimal places.
Right?
They started pushing the limits of low-precision training, dropping down to 8-bit or even 4-bit formats. They were essentially doing the same complex math, but rounding to 2 decimal places.
Which saves so much time.
Exactly. It's slightly less precise during the intermediate steps, but it is lightning fast and requires vastly less memory.
They also leaned heavily into something called distillation. Instead of training a giant model from scratch every single time, you take a massive, expensive model, we call that the teacher, and have it generate step-by-step reasoning.
Right.
Then you train a tiny, incredibly fast student model to simply mimic the teacher's outputs. The student doesn't need all that massive compute to learn the patterns from scratch. It just absorbs the distilled knowledge.
They were optimizing every single layer of the stack. They had to. They treated compute as a precious, finite resource. So while the U.S. was in the era of abundance, China was thrust into the era of absolute constraint.
Here's where it gets really interesting, though. Because right as the Chinese ecosystem is quietly re-engineering their entire underlying philosophy to survive this constraint, the meteor hits.
Late 2022.
Late 2022, ChatGPT launches.
It was a shockwave. It just reset the global board entirely.
The U.S. had successfully productized AI. It was no longer a research paper. It was a consumer product with 100 million users in basically 2 months.
Incredible speed.
Yeah. And the essay details China's rapid response to this. Baidu announces ErnieBot, Alibaba launches Tongyi Qianwen, iFlyTech has SparkDesk.
Right.
But underneath the frantic product launch cycle, the author notes that Chinese researchers were not actually intimidated by the raw power of ChatGPT.
No, they weren't. Actually, they were deeply inspired by it.
Really?
Yeah. They looked at ChatGPT and saw definitive proof that large language models were the correct path to general intelligence. The concept worked.
Right.
But they also knew their own reality. They knew they couldn't just replicate the thousands of state-of-the-art GPUs that trained it. So the realization was stark. If the U.S. wins on raw compute, China has to win on extreme algorithmic efficiency.
Wow. And this efficiency mandate brings us to a highly counterintuitive point in the essay regarding 2023.
Yes, the regulatory pivot.
Yeah, because in the U.S., labs are starting to focus on constitutional AI and alignment, like making sure the models don't say harmful things. But in China, the state steps in and releases the interim measures for generative AI.
Putting very strict guardrails on what these models can output and how they handle data.
Right. Now, I have to maintain some skepticism here as a Westerner. Because historically, tech moves much faster than lawmakers.
Yeah, for sure.
It's hard to believe state intervention in 2023 didn't cost these labs at least some momentum right when they were racing to catch up. I mean, usually when I hear government regulation, I think of red tape that just bogs engineers down.
And that is a very natural Western perspective, to view regulation purely as a speed bump. And certainly, compliance requires resources.
Exactly.
But the essay argues that in this specific context, the alternative to regulation wasn't unfettered innovation. The alternative was existential risk.
How so?
Well, think about it. If you are a Chinese tech giant and you're about to invest billions into a massive computing cluster, the worst thing you can have is ambiguity. If you don't know where the red lines are, you risk building a massive product only to have the state pull it offline overnight.
The paralysis of uncertainty.
Exactly.
Yeah.
The author argues that the 2023 measures provided ultimate clarity. By formally defining the boundaries of acceptable data processing and output, the existential uncertainty just vanished.
The rules of the road were clearly painted on the asphalt.
Right. And once the industry knew exactly where those guardrails were, they stopped worrying about hypothetical crackdowns and just channeled all their energy into building within those lines.
And building within those lines meant doubling down on the efficiency pivot. Since they knew the rules and they knew their hardware was fundamentally capped, they fully crystallized their architectural philosophy.
They stopped chasing the American ghost.
Yeah. They completely stopped trying to build a brute source carbon copy of GPT-4.
They shifted their entire metric of success. It was no longer just about who had the smartest model. It was about drastically reducing the cost per token while maintaining that frontier-level reasoning.
Which is where a sparse mixture of experts comes in.
Exactly. Mo architectures became their central focus.
The essay highlights MOE as a huge breakthrough for them. And for anyone listening who isn't deep in the weeds on this, early large language models were what we call dense. Meaning, if you asked a dense model a simple question like, what is the capital of France? It would activate every single one of its billions of parameters, its brain cells, just to generate the word Paris.
Which is incredibly computationally expensive. It's basically the equivalent of turning on the power grid for an entire city just to light a single desk lamp in one room.
That's exactly it.
Yeah.
But a sparse mixture of experts' architecture acts like a highly efficient switchboard. The model is divided into specialized expert subnetworks.
Right. It routes the traffic.
Yeah. So when you ask about the capital of France, the switchboard routes the question only to the geography experts. 90% of the model just stays dormant.
It's brilliant.
It uses a fraction of the memory, a fraction of the compute, and a fraction of the energy, but still gives you a highly intelligent answer.
And by relentlessly refining MOE and combining it with that low-precision training and extreme data distillation we talked about, they were engineering a completely different species of AI.
What?
They were building a model designed specifically to survive and thrive in a harsh environment where compute was incredibly scarce.
Which sets the perfect stage for the payoff. Years of severe constraint, years of this alternative, efficiency-first thinking finally culminate in late 2024 and 2025.
The arrival of DeepSeek.
Yes, specifically DeepSeek V2 and V3.
And when DeepSeek dropped, the reaction in the West was just absolute shock. I mean, Western labs and investors were looking at the benchmark scores, and they literally couldn't understand the math.
It didn't make sense to them.
Right. DeepSeek was delivering reasoning capabilities that rivaled the absolute best frontier models from Silicon Valley, but it was doing it at a fraction of the training cost and a fraction of the inference cost.
Because the U.S. ecosystem just naturally assumed that to get GPT-4 level intelligence, you basically had to spend hundreds of millions of dollars on compute.
But DeepSeek proved that was entirely false.
Yeah, and the essay points out that Chinese researchers weren't surprised at all by this.
Not even a little bit. Because they had been marching down this exact path since the compute wall hit back in 2021.
Right.
The author emphasizes a really crucial point here that is often misunderstood globally. DeepSeek is not a Chinese ChatGPT.
Right, it's not a clone.
Exactly. It is not a copycat model achieved through corporate espionage or just mimicking Western papers. It is the result of a fundamentally different evolutionary pressure.
It's like convergent evolution in biology. You know, like how birds and bats both evolved wings to fly, but their underlying bone structures are completely different because they evolved under totally different pressures.
That is a perfect way to conceptualize it. DeepSeek proved definitively that the American brute force scaling law was not the only path to the frontier.
So what does this all mean? We arrive at 2026, which is the present day in the essay's timeline. The author describes this current era as the convergence moment.
Yes.
What is the ripple effect of DeepSeek proving this alternative path actually works?
Well, if we connect this to the bigger picture, we see that the geopolitical and technological dynamic has totally flipped.
Oh, really?
Yeah. For nearly a decade, China was watching the U.S. to see where the scaling frontier was moving. But now, in 2026, the United States is actively adopting China's efficiency tactics.
That's wild.
Yeah.
But it makes sense because the U.S. hit a different kind of wall, right? They didn't hit an export control wall. They hit a physical energy wall.
Precisely.
You literally cannot build enough nuclear power plants fast enough to power the data centers required to keep brute forcing those scaling laws.
Exactly. The economics of American AI were becoming totally unsustainable. So now, American labs are scrambling to implement extreme MOE routing, sparse compute, and low-cost inference strategies.
The exact techniques pioneered out of necessity in China.
Exactly. Meanwhile, Chinese labs are continuing to push the boundaries of those efficiency techniques even further.
So the author describes the global AI landscape today as architecturally bipolar. It's no longer a single track dictated by Silicon Valley. The future of AI infrastructure relies heavily on both the American pursuit of raw hardware-driven scale and the Chinese pursuit of hyper-optimized algorithmic efficiency. DeepSeek was basically the bridge that forced those two parallel timelines to intersect.
It's a profound shift, and I think it's vital to highlight the author's closing sentiment regarding how we view these breakthroughs.
Definitely.
The writer emphasizes that DeepSeek isn't just a cold technical milestone or, a point scored in some geopolitical rivalry. It is a genuine cultural achievement.
It's a testament to human ingenuity under immense pressure.
Exactly. It was built by researchers who worked grueling hours with significantly fewer resources than their Western counterparts. And they were driven by intense curiosity and a real desire to contribute something meaningful to the field.
Yeah.
The author really frames DeepSeek as a gift to the global open source community. It proves that paradigm-shifting ideas don't belong to one country, one company, or one specific way of thinking.
And I think the core lesson from this Tech Reader magazine essay completely reframed how we think about innovation in general.
Absolutely.
Because we are so conditioned to view constraints, whether it's lack of funding, missing hardware, or strict regulations, as inherently negative. We think of limitations as chains holding us back from our true potential.
Yeah, that they just slow us down.
Right. But the parallel history of Chinese AI proves that constraint is often the ultimate catalyst. When you are starved of abundance, you cannot afford to be lazy with your engineering.
You have to strip away the excess.
You have to invent entirely new mathematical paradigms just to survive.
Scarcity forces clarity.
Scarcity forces clarity. I love that. The U.S. proved what happens when you give brilliant minds infinite resources. But DeepSeek proved what happens when you give brilliant minds a brick wall and tell them to find a way through.
It's incredibly inspiring.
It really is. Which leaves us with a fascinating reality to ponder. We've seen how extreme hardware constraints birthed a hyper-efficient software paradigm.
Yeah.
But if extreme efficiency is the new global baseline, what happens when an entirely new hardware paradigm drops? What happens in 5 or 10 years when quantum computing or photonic chips become commercially viable?
Oh, wow.
Will the labs that spent a decade fighting for every single ounce of efficiency absolutely dominate when they suddenly have access to quantum speed? Or even broader than that, if DeepSeek proved you don't need $1 trillion and a dedicated nuclear power plant to build frontier AI, what does this mean for the rest of the world?
That's the real question.
Right. If the blueprint for extreme efficiency is out there, open-sourced, could the next massive paradigm-shifting model emerge not from Silicon Valley and not from Beijing, but from a scrappy lab in the global south that realizes they finally have a playbook they can afford? Look at the roadblocks or limited resources in your own life or work right now. What if those constraints aren't actually holding you back, but are the exact ingredients you need to force your own breakthrough?
Something to think about.
Definitely. Thank you for joining us on this deep dive. Keep questioning the single narratives you hear, keep looking for the parallel histories, and we'll see you next time.